Well, good morning, everyone. Welcome to BRK 157. My name's Andrew Coates. I'm a software development engineer at Microsoft in Australia. And if you're wondering about the Tim Tams that got passed around, it's a very traditional Australian thing to bring Tim Tams. And usually the suitcase that you bring the Tim Tams in is much bigger than the suitcase you bring your clothes in, because that's a particularly useful thing to have a plentiful supply of. We're going to talk a bit about deploying Copilot Studio in enterprise software environments, and particularly we're going to talk about it in relation to a project that we've done with the Commonwealth Bank of Australia, who you'll probably hear me referring to as CBA all the way through. So that's the TLDR, Commonwealth Bank of Australia, CBA, and some work we did with them on a large customer-facing agent that they use for many, many customers. So we're going to give you a quick demo of what the solution, or what part of the solution looks like. And we'll talk about some of the technical challenges we came across, the solutions we came up with for those challenges, and then Baz in particular is going to talk about some of the futures for Copilot Studio, particularly in enterprise software development. And then we'll sort of talk about some stuff at the end. So that's kind of the plan for the morning. And so let's kick it off. This is quite an old recording of the agent in action. The agent runs in 3 different platforms, iOS, Android, and on the web. And it's part of a much larger solution that the bank has for their customers to interact with the bank. If you have a question as a customer of the bank, you can go into the CEBA chatbot service and start asking it some questions. And there are a number of questions for which we have canned responses, but many questions the customers will ask, we don't have a canned response for, so we can look it up and give you the answer through a generated answer. And so this capability looks fairly straightforward, but there's a fair bit that goes on behind the scenes, because this application has to interact with a number of different systems that are available throughout the bank. The chatbot itself has over 600 intents or topics, a number of complex API calls that need to happen back both from the bank's APIs into Copilot Studio and from Copilot Studio into the bank's APIs. We've got some really strict regulatory requirements for banking, particularly in Australia, and the bank's risk team has also got a number of really strict requirements about how these things should work. And as I said, over 10 million customers use this application on a daily, weekly, monthly, yearly basis. We also have a very large team of developers at the bank who have been working on this project. And so one of the interesting things that we're going to talk about today is how do you take that large team of both developers, but also IT administrators and makers, people who aren't necessarily traditional software developers, and integrate them into one team to deliver an enterprise solution based on a low-code platform. So I'm going to kick off some of the technical challenges. I'm going to introduce Shashank Verma, who's the engineering lead at CBA for this particular project, and he's going to talk through some of the technical challenges they had to deal with to use Copilot Studio in their enterprise environment. Shashank.
Thanks, Andrew.
Cheers, mate.
Hi, everyone. I'm Shashank. I'm a tech lead in CBA, handling the chatbot and the voicebot platform. So I'm going to talk about the challenges that we had. So the CBA chatbot we had is a fairly large chatbot with 680 odd intents, which means that there is a complex customer journey and workflow that we allow for our customers. During the migration, what we faced was how do we migrate all these legacy intents and conversation to the new system while effectively managing the customer experiences. The approach we took was we actually going to do a one-to-one mapping, which means that mapping all the legacy intents to the new Copilot Studio topics. And to be able to effectively do that, we did 2-phase approach. So we did a programmatic conversion from the legacy to the new one. We also did a manual one. This hybrid approach helped us to migrate the chatbot in 5 months' time with 0 defects. That was amazing from the CPS point of view. Also, to actually bring in the experience back into the chatbot, we had to integrate with our APIs. Now, APIs in CBA is a highly regulated area. We have to care about data integrity, security, and policies as well. And we're going to talk about later how we actually integrated all of our APIs into the CBA chatbot. Now, the slide I'm showing is only a small part of Copilot Studio. If you look at it, the In CPS, we have got, Copilot Studio has got a fallback topic, wherein on the right side is all the bank infrastructure, where we're doing a whole lot of RAG solution as well. What this tells about is that CPS, Copilot Studio, is actually a really small part of our CEBA chat platform. All the backend calls happens into our system, allowing the customer experience to be really enhanced and enriched. In terms of the extensibility of Copilot Studio, this is where we had a breakthrough win for the Galaxy program. In terms of the ways of working, so CEBA has got a really large team. We've got conversation designers, we got all our engineers, including developers, QE, platform engineers, automation engineers. Cyber has been a big part of our journey as well. So the challenge was, how do we actually bring all these teams together into delivering the program? What we did was we actually went towards and used the low-code tool that we have got in Copilot Studio, but brought in our SDLC practices, same as any of the pro-code solution. So items such as shift-left strategy on all of our testing, code quality controls, 100% audibility of any of the changes that goes in was done through with our GitHub Actions and GitHub itself. In terms of working with CDs, what we did was we made sure that they can actually work without having to worry about any of the SDLC practices, learning new tools such as GitHub and GitHub Actions and any of the CI/CD tools. And the engineers can actually focus on building the wraparound of the automation testing framework, the release processes, all of the API builds, and all of the native builds. This helped us to actually run our journey into parallel streams. So the conversation designers would actually work on all of the customer experiences and workflows. The engineers would actually create all of the APIs and native development. All of this had to be done with our bank's really complex policies and responsibilities. So in terms of making sure that we have got 100% data integrity, we've got all the security compliances done. Those are non-negotiables for the bank. We can't get away from that. We were able to integrate Copilot Studio with all of our integrated architecture. So such as role-based access control. We had to bring in access control into our ecosystem to make sure that people don't have the wrong access. Again, low-code solution can be problematic sometimes, but in terms of Copilot Studio, we were able to bring all the RBAC processes as well. In terms of bringing in all of our security policies, so making sure that the Power Platform of the Copilot Studio can have all the firewall for us to secure our chatbot, whether it's data coming in or data going out. We had proper firewalls around that, so that helped us quite a bit as well.
So you can talk.
Over to you, Bas.
Yeah, thank you, Shashank. So as Shashank described, there's a mission-critical agent that has been migrated from a legacy system in a one-to-one fashion. That legacy system is highly effective at handling these type of customer questions. So we need to make sure the system stays in place, behaves the same way, which includes bringing over these highly customized troubleshooting flows that have been built over the years. Those start to become very large. And so what we see inside of Copilot Studio, it's a software as a service platform. It's a low-code tool. We don't want to cause the low-codeness of it to have customers make any sort of trade-off. So we want to make sure we are secure, compliant, low latency, high availability, and we have all the right properties that you expect of a mission-critical solution in our system. And so this means having very low latency on an agent that has a declarative definition that exceeds 100 megabytes internally. So there's a lot of different content that we have to manage, and we have to make sure that every request can be served in very low latency. It also means our engineers need to optimize. When we're optimizing things, we need to optimize things for every customer. And if we see hotspots and we see issues for one customer, the optimizations we apply to everybody. So that is a benefit of having a large concentrated engineering team that is able to optimize a platform that serves millions of agents, as opposed to developers going into each individual agent and optimizing them. The other sort of set of challenges that we start seeing is even our authoring canvas has it's a visual designer for building agents, and we have these like very large complex workflows that were imported and programmatically created from an external system that create giant workflows that are hard to even conceive to create manually through the tool. So we had to do a lot of optimizations there to ensure that our user experience is performant. And there are other challenges we faced along the journey, including we have some process called query rewrite, where we are taking context and conversation history to produce the right search queries for a backend system, to do optimizations there. We increased the instruction limits, and we did all kind of things that we needed to do to get a generative AI solution ready for like a large-scale, mission-critical enterprise solution. And so all of the things that we've done and we're describing here have been applied to the platform in general. So this is available to anybody here today. And I wanted to dive into an example of how we optimize performance. So this was sometime last year, where we saw, because of the large scale of this agent, that we're hitting certain hotspots in the system. And so we basically, the way that we approach these is that we use our monitoring, we detect hotspots, we understand where in the system they're caused, and then we have a breakdown of what the root cause could be. And so we had, for example, some optimizations that reduce how many database calls we make during a single conversation turn. And then what's interesting is we run about 9 different AI models, from a message coming into our service to understanding what it means. And even in the case of generative AI, we still may use our own AI models to like scope or tune or optimize the incoming data. So all of this is running like in our process, and we optimize this for low latency. So we did a bunch of like optimizations that dramatically reduce the internal latency. And the way we detect it is we have these flame graphs that we're looking at every day in production. And for example, this scenario here was Shashank and team running a load test on the system, and that clearly like points out, oh, there's a hotspot, and we know exactly it's in this area of the system, which we then use to sort of create the breakdown and optimize the system. So we're always looking for these, and we're always optimizing it. And generally customers just sit back and relax, hopefully. Moving on.
So as part of this process, we asked a series of questions, and I'm going to talk about 3 of them today, and I'll mention some of the others at the end. But we particularly looked at some interesting questions that are really relevant to enterprise software development and integration of Copilot Studio into that platform. So the first one was, how do we use the bank's existing APIs to enrich agent conversations? Because pretty much any enterprise system you're going to build that includes Copilot Studio will have other things as part of it. It'll have, in the bank's case, the ability to look up your balance, or the ability to stop your card, or whatever else it happens to be. In other situations, you'll have other. So, for example, if you're doing hotel bookings, then a room booking system of some sort might be an API at the back end. You need to be able to communicate back and forth. So, how do we go about doing that? I've got a really high level of the architecture that we used for this particular agent. You can see on the left-hand side at the top there are 3 different apps that the customer could come through: an iOS app, an Android app, and the web app. They all come through a front-end API that lives in the bank's infrastructure. That front-end API actually intercepts the message and decides whether it should go to Copilot Studio or whether something else should happen. There are a number of other things that API could do. If it decides it goes to Copilot Studio, then it redirects through an API, in this particular case, the old Direct Line API, to Copilot Studio, and Copilot Studio takes over that particular utterance and decides what to do with it. If it needs to go and talk to a back-end system, then it needs to reach back into the bank's back-end systems through a firewall and talk to the bank's back-end systems. And that might be to go and do that Azure AI search we talked about before. It might be to call the bank's specific guardrails to make sure that when we're sending information back to the customer, it complies with their requirements around things like tone, or whether or not it's giving financial advice and those sorts of things. Things that aren't necessarily built directly into the system's guardrails. So the bank needs to be able to provide their own. or whether it needs to go back and talk to the APIs for things like balance or stopping a card or whatever else happens to be. So that's all done at the moment through a Power Automate call, which goes back through the firewall. Now, the reason that it needs to go through Power Automate is interesting. It's actually a legacy thing. Normally, nowadays, we'd probably suggest that you have a custom connector you call directly from Copilot Studio or set up as a tool in Copilot Studio. But back then, we needed to go through a custom connector that needed to be run in Power Automate because we had some specific requirements for accessing the back end. The bank either needed us to use MTLS to communicate with the back end systems, or a payload signing, payload verification service to get through their internet-facing firewall. And to do that, we actually used a custom code in the custom connector to run that payload signing and payload verification piece on top of the custom connector. Now, this is great, except custom connectors with custom code have a couple of restrictions. The first one is a hard timeout. If you take more than X seconds, where X is changing a little bit at the moment, you just get chopped and it stops. So you need to make sure that your code runs within that time period. Not only your code, but any code that you call, any downstream calls that you make. So that's sometimes can be quite restrictive. So if you have, let's say, a 5-second timeout limit, your code itself might take milliseconds to run, but a call out to an external service could take any amount of time. And that, if it's more than that cutoff, that threshold for cutoff, you'll get chopped. The custom code has a number of really good namespaces. It's a C# scripting custom connector, custom code piece, but it's a limited number of namespaces. And so if you have a namespace that you need in that custom code and it's not available, then sadly you're out of luck. And then finally, custom code for custom connectors run on their own Azure a function infrastructure. And if they don't run all that often, then there's sometimes a cold start issue with getting them up and going. So you need to handle that as well. So that's some of the things that we needed to deal with, all of which we did deal with, by the way, as part of the process. And if you want some details about that, come and see us. We'll talk in some more detail. But the thing I want to call out here is that because the platform is evolving so much, we've now been able to move away from a bunch of this custom code, custom connector piece into using the API management tools in Azure. We're talking via VNet and OAuth authentication using the bank's IDP to be able to overcome some of these things. So I think it's a really important point to note that one of the great advantages of adopting this SaaS platform is you continually get these incremental updates that you can take advantage of as you go. For the next one, I'm going to hand over to Shashank.
Thanks, Andrew. Going to talk about how are we integrating our makers into our enterprise development practices. So in Bank, one of our key roles for development of our chatbot is conversation designers. They are not usually engineers by trade. So while they are experts in all of the tools and design conversation, we need to make sure that we don't have to skill them into or upskill them into the traditional software developers. So what we did was we had, as I said previously, we had parallel streams wherein the engineers are focusing on all of our CI/CD tool, which we built into Power Apps. The engineers are taking care of all of our testing as a shift left methodology, and also making sure that everything is part of our GitHub. So how we approach this, right? So we built a custom Power App to abstract away all of the developer practices so that makers don't have to learn Git. We use GitHub Actions in the back, wired through the Linux runners. We worked on the AM Accelerator as an open source tool and enhanced that. I'm just going to show you through what it actually looks like. So this screen talks about all of our solutions that we have got for our chatbot. We don't have one master chatbot, so we have done in terms of the connectors, integrations, and the actual chatbot, wherein the makers can actually go on the tool and select what they want to deploy into which environments. We have got, I think, around 15 environments that we are maintaining at the moment. So it's a fairly large-scale team that we have got. So the makers can actually go and pull up the changes from different environments if they want to. They can also commit their changes in terms of moving to the next environment. Now, what I'm showing you here is mostly around our non-prod tenant environment. There's a separate process, an automated process to do a production tenant changes as well. So the makers can actually go and commit their changes, and the makers can actually now go and deploy the changes as well. Now, on the screen, it looks fairly simple, but we had a bunch of GitHub Actions running on the background, which is syncing the content and the chatbot in real time to be able to do pull request merge and to be able to deploy into the next environment whenever we need. Andrew's going to talk about the ALM architecture.
Thanks, Shashank. So, as Shashank said, it's a pretty complex architecture in terms of ALM. One of the big things we had to overcome is that the bank insisted, quite rightly probably, that their dev and test environments be in a completely separate tenant from their staging and prod environments. And so deploying across tenants was something you needed to be able to do. It's not something you were able to do with the Power Platform pipelines. But what we could do is we could use GitHub to do that. And so you can see there we have a single source of truth, which is our GitHub repository down in the bottom right-hand corner. We have our non-prod tenant and all of its associated environments on the left-hand side, and the prod tenant and its associated environments on the right-hand side. And it allows us to run all of our software development lifecycle processes exactly as you would for any other enterprise software development practice. So we still run tests. We still do deployments through pipelines. We still have release gates. All of that stuff works as you normally would, but we're using the built-in capabilities of the GitHub Actions and the runners that we can run on our VMs to run all of the processes we need to run as part of that deployment. And you can see there's a bunch of things that need to go in and out of the various environments. We need to open up a few firewall ports and so on to be able to get in and out of the cloud environment. But all of this is completely possible. And of course, I would recommend it highly if you're doing enterprise software development. To do the testing, we took a fork of the PVA test framework that the PowerCat team built. We're probably going to migrate that in the next little while across to the test engine or the Copilot or the Copilot Studio Kit. And it allows us to automate testing as we go through and run a number of smoke tests so we can check that what we're deploying is not breaking the system. The third thing I want to talk about is this idea of monitoring and alerting, also a key part of any enterprise software development process. The bank, of course, already has a great deal of monitoring and alerting infrastructure for the rest of their IT infrastructure. And so while it's lovely that the Copilot Studio has some great analytics and monitoring built into it, we needed to make sure that it was integrated with the entire operational capability of the bank. So to do that, we took advantage of the way Copilot Studio outputs information through application insights. And we built a number of custom dashboards and alerts as part of that process. In addition to that, we export the conversation transcript into a enterprise data warehouse that the bank uses to do analysis and postmortems, as well as conversation analysis in their back end. So here's, as I say, an example of that sort of dashboard. We ended up writing some pretty complex Custo queries. This particular query allows us to monitor in very fine-grained detail how long does each node in a topic take to execute. And you'll get outputs a bit like this, where you can see in this particular case, the first call, where we've got a bot message received, it took about 16 milliseconds to send a message back. And the next call, it took about 1.8 seconds. And we could see which node it was that took that time to execute. And we could go and talk to the people who were responsible for that node as part of that process to make sure that we could either justify or remediate whatever was going on in that particular node. So, of course, all of that was done with what Copilot Studio was capable of, I guess 18 months ago when we started, because we had to draw a line in the sand and say, here, we're building from here. We've adopted a few of the new things, but there's lots more that's coming out in Copilot Studio that really enhances our ability to do enterprise software development. So to talk about that, here's Baz.
Thank you, Andrew. Some of the things I'm talking about here have been covered in other sessions or will be covered in other sessions, and there's links to those at the end of the slide deck here. But I did want to bring these up in the context of this project and this sort of large-scale development practice around these mission-critical agents. And I think the first feature that's very interesting is our native source control integration, which is now generally available. What it means is you can take your agent in your environment and connect it to a source control repository and basically make commits from the UI directly. And we've seen the custom sort of ALM tool with functionality that's very similar, and we're trying to make that available to all customers. And it basically just means you're in low-code, you're in a low-code environment, but everything you do is source controlled and is managed and is governed in the same way that you would expect any software to be managed. And I think that's the general theme is while we are low-code and we try to make it more productive and easier to build, we do not make you compromise on any of these, observability, latency, reliability, governance, and so forth. And especially in the case of a Fusion team, is what we call it. We have software developers, we have conversational designers, we have prompt engineers, we have makers. They all need to work together on a single platform. And we try to make it more productive, like editing instructions, editing tool descriptions it's been, the bar has been lowered significantly for developing agents, but we still want to do that in this environment that allows you to have it be set up. And so source control integration is an essential element of that, including typing change notes and commit messages. So we're trying to map it to the right underlying platform without creating a very complex user experience. The other feature that we've announced is support for model context protocol, and there's a session, deep dive session on that tomorrow. This is it's a different take on integrating backend APIs into your agent, and especially if you have a team of software engineers that are collaborating with a team of agent builders or agent makers. You have these tools, you have APIs that many APIs were not designed for generative AI consumption. They were designed for, like an app calling it or an automation workflow calling it. But there's all kinds of inputs that will be hard for an AI agent to understand. And so the model context protocol is great because you can reduce and scope the input specific to what an agent should be understanding. And most importantly, the tool descriptions and input descriptions and the things for the agent to understand what the API can do are provided by the server. So if you have a multidisciplinary team, you can have a team that is maintaining the MCP server that has validated it for use by agents, but is not necessarily responsible or tightly coupling it with the agent itself. So you can deploy it independently from the agent. You can validate the sum of parts, but it helps you distribute larger scale agent development. And so the way it works, it's kind of like plugging in a connector, an API, but with this dynamic metadata discovery element added into it. It will still have the same, the MTLS we talked about, the VNet integration, the other security best practices all apply to MCP server integration because it uses the same underlying connector platform. And we're also starting to build out a set of pre-built MCP servers for the known systems that we have, for Dynamics, Dataverse, and we're also working with many third parties that are bringing their MCP servers onto our platform or developing new MCP servers to integrate with Copilot and Copilot Studio. And of course, there will be, there is detailed tracing and integration. You'll be able to see all the inputs and outputs and the mappings of the MCP tools just like you would any other API. So it's very important for Fusion team development to have this decoupling. The other feature, as was shown yesterday, is multi-agent orchestration. With the influx of generative orchestration and tool calling, where the large language model is deciding which route to take, we see that if you start adding, like 50, hundreds of tools, it starts to lose accuracy and the model starts to get confused. So our solution to that is to build a hierarchical setup or a graph, depending on how you think of it, and basically delegate tasks of sub-problems to smaller agents that are able to deal with that have fewer tools, that have more specialized knowledge for it, and that have specialized instructions. Of course, we don't want to force you into, or say, microservices hell because we decided that this is how you break down orchestration. So we have basically two ways of doing it. You can build agents that are basically embedded within your main agent and that really only serve a purpose of breaking down the orchestration problem and making it more digestible. But if you have agents that are already built, or you want to deploy them independently, or you want to manage them separately, you can connect them together. And this is also where we're working with various internal partners like Foundry and Fabric to have more native integration, as well as our SDK, where you can basically plug in any external system as an agent into Copilot Studio. And this is also an area where we're investing more. So you'll hear more about A2A integrations. If an agent that understands the A2A protocol, will be able to plug it in, as well as any basically third-party endpoints. So if there are providers that we work with that have an A2A agent, we'll bring them in natively. So we should also expect that this list of tiles of systems that we integrate with natively will expand rapidly in the coming months. So yeah, and this enables cross-platform orchestration as well. So if you have an external endpoint built within random programming language deployed somewhere, you can still plug it into Copilot Studio and have a multi-turn integration with it. And again, this is very similar to MCP, where it helps you take a very complex problem and break it down and allocate it to different teams and make it into a cohesive end-to-end solution. The architecture around multi-agent is, if you look at the anatomy of an agent, you'll see generally we have an orchestrator that decides how to route incoming requests. And there's topics, and especially legacy agents will have lots of topics. They might have hundreds of topics. There's knowledge sources and there's tools. The tools have different implementations. But now so just to recap, we also have these agents that you can now nest into your main agent to break down the orchestration, which themselves have tools and knowledge and so forth. So you can create these smaller units that you work with. And then on the right side, you see all the systems that we currently integrate with. And as I mentioned, that is expanding as we're working with various partners. And diving specifically into the Agents SDK, this SDK helps you integrate any existing AI system into Copilot and into Copilot Studio, into Teams, and basically any like Microsoft platform, no matter how it's built. So of course, you can use Copilot Studio to build your agent, but we don't force you to. You can use any platform you want. You can use Azure AI. You can use basically any sort of backend. And provide like a high fidelity and high quality user experience within Copilot and within Copilot Studio, and publish to various channels, including Copilot and Teams, as I mentioned, but also various third-party integrations like Twilio and other backend systems, which you'll see if you're deploying a large-scale mission-critical agent. You'll likely want to be embedded in certain like social media platforms or other systems where customers can communicate with you. So this is also facilitated by the Agents SDK and the underlying service, as well as through Copilot Studio. Again, highlighting the Fusion team approach here, where we know that low code is like the most productive way to build an agent, the most productive way to get started. You can do a lot with it, but sometimes you may want to just write code. You may want to do something in a backend, in a custom system, integrate with an existing agent platform, and that's where the SDK comes in. In general, we have a principle called no cliffs, which means just because you started with Copilot Studio doesn't mean we bring you to the edge of a cliff where you're no longer able to continue. We always want to give you a way out and to be able to integrate whatever you need to integrate. Which brings us to the next topic, the ability to bring your own model from Azure Foundry, which means you go to Foundry, create a deployment, set up a model, and then go into Copilot Studio and use it there. There are two different features that we're announcing as preview. One is for prompts, so if you're building prompt actions within Copilot Studio, you can switch the model. There's several options that are out of the box. But you can also switch it to your own deployment in Foundry. So there's, even if you have a fine-tuned model, you can pick that. So this helps with certain regulatory requirements or very specialized use cases where you want to use your own specific model, or if you just know like this particular model works really well in this scenario, you can apply it there. And the other feature we have is for generating agent responses from Copilot Studio. So this means whenever Copilot Studio uses any kind of generative AI to produce a response to a user, you can choose which model Copilot Studio should use to produce that response. So this doesn't impact how tool selection happens and how orchestration happens, but it selects the response generation model. And so it's an agent level configuration. So you can also apply like these, if you're calling into other agents, you can have agents that are working on subtasks that use a different model to produce responses to the user compared to your primary agent. And this is also an area of continued investment for us. So you'll likely see updates on being able to change the model even for orchestration itself in the future. Our philosophy here around managing the models, we have a large data science team internally that is always constantly optimizing and deciding which model we should use for which scenario, and especially a pipeline we have on like tool selection and generating responses and so forth. It may use several different models, including models we have fine-tuned internally to optimize the scenario. And this is something managed by Microsoft, managed by the SaaS, and that's continuously updating. Now, as a customer, you do get to have some control over this. We don't just like roll out new models. So we have a setting where you can you can choose whether you want to use the vNext of the model or the current model, and you'll have a short, few weeks window of time where you can try out the next model and maybe make any prompt adjustments before we start rolling it out more broadly. But as a SaaS platform, we have the responsibility for not breaking customers. So we do run extensive tests in the backend, and sometimes like in the background on customer transcripts to see whether a new model would break a response. And we use a large language model to judge whether the new model would produce an equal quality outcome as the previous model. So this is how we try to manage as a platform model upgrades for customers, because models are very rapidly evolving, and GPU capacity is scarce, and models are bound to GPU, so we have to sort of keep it moving, and that's our responsibility as a SaaS. Now, if you think this is not for me, you can switch to your own model and pin your agent to use a specific model for the responses. Yeah, and we have there's tons of models in Foundry. There's task-specific, scenario-specific models, fine-tuned models. So there's a lot to choose from there. And finally, the feature that helps with the same sort of Fusion team type scenarios is our extension to Visual Studio Code. You can try it out. If you go to Open Visual Studio Code, go to the marketplace and search for Copilot Studio. You'll find an extension. The extension allows you to clone agents like you would clone from a Git repository. So you can, on your machine, take a Copilot Studio agent, bring it to your machine locally, and start editing the agent. You'll get syntax errors, highlighting, you get autocomplete on the formula as well as on the structure. There's documentation that's sort of integrated in the autocomplete. There's references, you can go to the definition and so forth. So this, it just launched like 2 days ago. There's updates coming out every day. It's still, an early preview, but you'll see it evolve rapidly. And the idea is like it treats the Copilot Studio environment as a sort of source control provider. So you can push and pull to your environment to keep it in sync with what's on your machine. But it does. Yesterday we demoed it working in airplane mode, so it does run fully offline. So you can play with your agent. You can use GitHub Copilot. We see it's very interesting and efficient. You can use GitHub Copilot to author trigger phrases, messages, instructions, tool descriptions, and it's a quick way to build something out. So yeah, this is I'm a developer, so this is one of my favorite features. I'm very proud that we're able to do, these sort of code behind editor experiences. And this, like I said, it's an early preview. It'll get integrated with the native source control and also with solutions. So we want to make sure when you export a solution, it comes out in this format that is natively understood by VS Code and it's understood by our toolchain. Great.
Thanks, Buzz. Yeah, that's really cool. Buzz is being super modest, by the way. When he says he's a developer of that extension. So, not just a developer. It's very, very cool. He talked to me about some of the leak code issues that he had. Right, so I did promise that we would touch on some things that we didn't have time to cover today, but I thought were super important that you talk about in enterprise software development. So the first one is testing and evaluation. And this is something that we've done a lot of work on, particularly early on. How did we automate the process of checking that the changes that we made are actually beneficial? And so we talked briefly about the PVA test framework and adopting that, because that was kind of state of the art when we started. Now the Copilot Studio Kit and the Power Apps test engine is becoming more and more to the fore. And of course the integrated testing as part of Copilot Studio, you've probably seen in some of the demonstrations over the last little while here at Build. So that's certainly something I want to emphasize it's super important that we haven't had time to cover today. Security and governance and DLP, again, being part of the Power Platform, this is a huge part of the things that you need to do in enterprise software development. You don't want data leaking. You want to make sure that the people who have got access to the data are the people who are supposed to have access to the data. You need to make sure that the people who have got the authority to deploy an agent or to change an agent are people who are supposed to be able to do that. And so all of that, of course, is built into the system, but you need to make sure that you've taken that into account when you're setting up your teams. And finally, the concept of infrastructure as code. There's a lot of work going on behind the scenes to make sure that it's just as simple to deploy a Power Platform set of infrastructure as it is to deploy an Azure or some other cloud-based infrastructure using infrastructure as code at the back end. And so at the very end, there's a bunch of links, and one of the links is to the Terraform provider for Power Platform that I'd really encourage you to go and have a look at if you're starting to roll out Power Platform as part of your enterprise solutions. So I guess we've got some key takeaways. So I'm going to start with Shashank and ask you for your key takeaways, please, mate.
Look, I think my top three key takeaways are: don't change your SDLC processes and your policies to accommodate low-code solution. Copilot Studio is extendable enough so that you can actually use your same automated processes to deploy your chatbot. In our case, it's called Zeba. Focus on data integrity, security, and policies throughout the change processes. Working with a SaaS solution, especially in a bank, is not a trivial work for us to do. So focusing on your data and security all the time is really, really important. And the lastly would be, in our case, no one has got access to our prod tenant, which means that everything is automated end-to-end for all of our prod environments, including for our chatbot. So that tells you that making sure that bringing in your SDLC process, your automation, your shift left strategy is really, really important for your Copilot Studio. Bas?
Thanks, Shashank. Yeah, so one thing to be mindful of is Copilot Studio evolves very rapidly, and there's new features coming out. There's a huge wave of features that came out during build. And we want to make sure that we do not break customers while we're rolling out these new features. So my main takeaway is look at the settings page every few weeks and see what has shown up, because there are a lot of settings that we're enabling by default for new agents that you're building that we don't want to enable for existing agents. Generative orchestration is one. There's using the model knowledge, using being able to connect to that agent from other agents. So there's several features that are just coming out that will be enabled by default that are not enabled for existing agents. So please take a look at the settings page every so often. You'll see a bunch of new stuff pop up. You'll see the model selection and so forth. We of course make it available to all the existing agents, but we want to make sure the experience is preserved there. And so that, yeah, just keep a watch on it. Yeah.
Thanks, Baz. I guess my takeaway is I've been a software developer for 40 years now, getting on for, and not all that time obviously in low code, but I do love working in low code because it makes me so productive. But I want to emphasize to you that Copilot Studio and Power Platform are really both an excellent development environment, integrates well with the rest of your enterprise systems, tools, processes, and all the things that you need to do. And so I'd strongly encourage you, if you haven't done so already, to start using Power Platform, particularly Copilot Studio, to make yourself and your users much more productive. Folks, I do want to call out some related sessions, and then we'll take some questions in a moment. Some of these happened yesterday or the day before. Some of them are happening tomorrow, but they're all going to be available either in person if they're after now, or online if they're before now. So please do go and check those out. And particularly the Gary and Salem's session yesterday around multi-agents. That was super, so please do check the recording of that out. I did promise you a bunch of links. Copilot Studio documentation, the implementation guide is a great place to start if you're thinking about rolling out Copilot Studio from the PowerCat team. The test engine and the Copilot Studio kit I talked briefly about. The Power Platform CLI for being able to do things programmatically with Power Platform solutions. The Terraform provider I briefly touched on, and of course right at the end there, the Visual Studio Code extension that has been released in preview for in the last day or so. So folks, with that I'll say thank you very much, and I'll open the floor to questions. Please, if you do have a question, come up to the microphone in the middle there.
So my question to you is that now you have gone through this journey of using Copilot Studio and actually doing something pretty mission critical. Would you continue to use Copilot Studio for additional agents, or do you see that maybe you would use M365 Agents SDK for some other use cases? And when would you go in that direction compared to Copilot Studio?
Do you want to start with that one?
Yes, really good question. In CBA, we are still working through in terms of which agents we're going to use where. Obviously, the extendability that we have got with the Agent SDK is going to help us quite a bit in terms of bringing our own agents that has already been built. In terms of using the agents from the Copilot Studio itself, that is going to definitely help us out in the test, learn, iterate approach out of it. We haven't made a call yet, to be honest, where and what agents we're going to use where, but the extensibility is allowing us to bring the entire ecosystem together in an open architecture way, so that we're not tightly coupled to MCS. We can actually bring our own agents as well.
I think that's the important point you made there, is you're not tightly coupled. So you don't have to make a call. You can pick and choose depending on the various capabilities of the people who are building the agent, where the agent's coming from, where it's getting hosted and so on. All of that is something you can take into account. So like any good software developer, the answer is it depends. But it depends is a really important way to be able to answer these things. And Copilot Studio and the Power Platform allows you to use the it depends answer as opposed to saying you must, which I think is super important. Thanks, great.
And I would say, if I look at the overall set of customers, one of the main complaints historically that we've had around building agents is that you need a multidisciplinary team. Like you need software engineers, you need AI specialists, and you need all kind of very expensive people just to build a fairly simple agent. And this is where Copilot Studio shines. And especially because agents, they're not that heavy on like software code. They're more heavy. They're like very content heavy in many cases, where it's either like it used to be pre-cooked like Q&A type of content that you don't use like software engineers to manage the content on a website. It's a very similar concept. So you're managing instructions, tool descriptions, other type of concepts that you don't really want to use. You don't always want to write code to do that. In some cases, you're just trying to rapidly iterate and test and develop. So that's where I think a low-code solution is a very good fit for building agents.
Cool.
Hi, Scott Harms from Valtech. Great presentation. My question is around testing and monitoring. So Azure AI Foundry has a lot of great tools built into it. Are you able to leverage those to test the Copilot Studio? And then also, how do you balance sort of pre-release testing and then post-release monitoring and evaluation for things, again, like content harm, prompt injections, things like that? Thanks.
Yeah. So on monitoring, if you connect your agent to Application Insights, you will see an extremely detailed feed of everything that is happening within the agent. You can even, for debugging purposes, turn on getting more of the sensitive data in there as well. So if you're developing something locally, you'll be able to see like the entire feed, including the transcript in there, which of course should not be enabled in production scenarios. But you will get the same level of observability, and including I think the one benefit as well of the low-code solution is we understand more deeply what the agent does and how it behaves. And so we're able to build out-of-the-box analytics that understands the flow of a conversation. Like the user triggered this tool, and the tool had 3 inputs, and we didn't fill out 1 input, and the user left, like abandoned their session. That is not treated as a success, and if they did fill all the inputs, they were able to execute the tool, and then they left. That is treated. So there's some default analytics that we can make available in the platform to help you functionally improve the agent. That is harder to do if you're building with with pro developer tools. And in terms of testing, you'll see it's also being announced this week. There's an early preview of being able to test your RAG and your Q&A type scenarios natively within Copilot Studio, and we have plans to expand that into like a full-fledged, basically low-code test suite that integrates with the other Power Platform testing tools. But I think we also have the ability to use the Foundry evaluation on the Copilot Studio agent.
Absolutely. So Scott, that's a great question. One of my colleague teams in Australia is doing a lot of work on that integration piece to be able to feed stuff back into Foundry and use either the Foundry built-in evaluators or or custom evaluators you can host in Foundry. And they're looking at it from, I guess, 3 different points of view. One is it's just taking the transcript out of Copilot Studio and doing it there. The next one is actually getting Foundry to run a series of tests against a Copilot Studio agent, and then take the results from that. And then the third one is the whole monitoring and reporting piece as part of Foundry. And then it's a super important part of what we do as enterprise software developers is that process, because the last thing I want us to be guessing is whether the changes we've made are good or not, or whether people are trying to break our system. We really want to know. And that integration process is super important. I would say that they're sort of most of the way along that journey so far. They've certainly got the guts of that happening, and we're expecting that they'll release that as an additional piece of capability, probably as an open source piece, maybe integrated into some of the stuff the PowerCat team do, or maybe some other way in the next couple of weeks, maybe a month. So happy to give you a business card if I can find one still, and you can ping me, or my contact details are on the site. Yep.
Perfect. Yeah. So my question is one of scale. So as these agents get used more and more, we know that the models have token quotas and token limits and context windows. And what happens in Copilot Studio if you've got a whole bunch of users and the model that you're hitting hits its token quota? Does Copilot Studio take care of that horizontal scale in the back of multiple models? Or do I have to deploy more? Obviously, if I bring my own, how do I manage that scaling across? Like, do I have to put in an AI gateway? Those are the kind of questions.
Great question. So the short answer is for any of the models that are brought in from Copilot Studio, the underlying GPU capacity management is handled by the Copilot Studio engineering team. And so we make sure, we have a pretty sophisticated demand forecasting things, and we make sure we have the right GPUs available in the right locations. And it's a matter, for you, it's just a matter of making sure you're not running out of credits, basically. But there's no specific GPU management that's required by customers when they're using Copilot Studio.
A higher level question, probably for Shashank. You said you had a previous application that did much of the same things. Why did you decide to change to the new one? How much did it cost, and how long did it take? And what was the return on investment?
Great question. I'll start with how long. It took us 5 months to migrate from the legacy chatbot to the Copilot Studio. 5 months with the entire team. So we got a team of around 30-odd engineers, conversation designers, obviously a lot of product owners and business people as well. We all work together. Costing, I probably can't say that, how much it's going to cost us. But from the 5 months point of view, it also depends on how large your previous chatbot is. With our chatbot, it handles most of the customer conversations, whether it will give you via the enriched data from the API or will tell you where to go. also bringing our own RAG solution as well. So it's quite extensive in nature, and that's why it's pretty big. Why we moved up? Copilot Studio was a great tool for us to use, and we had some contract finishing up as well. So we wanted to move to the next generation of the chatbot.
Okay, just trying to understand, the thought process behind it and what it took. Are you modernizing? Is this a chatbot that just gives answers, or does it do things? Can
No.
I pay bills and move money?
It does workflow. So as an example, we have got dispute journey. The customer can come and raise the dispute. So it's not just a knowledge base. It goes back and forth. In terms of balance transfer, I believe it will tell you where to go in the app to do that.
But it won't do it for you. Okay.
Yeah. So we want to make sure that we don't duplicate our work as well. So as the app is getting changed and evolving, we want to make sure that we're not duplicating the effort in every single area. So where it's most important, where the customer comes and asks for help, we definitely create that workflow in the chatbot. Where it's a simple balance inquiry, as an example, we tell the customer that here's the link to go and view them.
And Copilot Studio supports sending events to the client and basically integrating with client-side workflows. There's even client-side, like if you use like an OpenAI API, you'll have this function calling that tells you which function to call and doesn't really execute the function for you. Copilot Studio generally execute the function calling, but there are also actions that execute on the client, and so this allows you to integrate with existing flows or UI elements that exist within the application with the conversational aspect of the agent.
So in other words, your chatbot could open your app and say, "Here's."
Well, the chatbot is integrated
chatbot
into the app.
in the app.
It lives in the app, and so it can look as though it's exactly the same thing. It just pops that particular part of the screen up.
Great. Thank you.
Just on the ROI, I want to go back, right? So our previous chatbot had around 78% of NLU match for all the customer queries. And the new one, it's around 91%, I believe. So just in terms of capturing the customer intent and to be able to help the customer out has got massive ROI for us because we're not directing the customers back to talk to the human or call us. So that's been great.
Folks, we're going to leave it there, but I want to say thank you both to you for coming and listening, but also very much to CBA for helping us on
No
the
problem.
journey.
Thank you for having me.
Please don't forget to fill in your evals.